Hello viewers, this is Dr. D. Rajalakshmi, Associate Professor, Department of Computer Science and Engineering, SRM Institute of Science and Technology, Ramapuram campus. In today's session, we are going to see about first come first served scheduling. CPU scheduling is the basis of multi-programmed operating systems. The objective of multi-programming is to have some process running at all times in order to maximize CPU utilization. Scheduling is a fundamental operating system function. Almost all computer resources are scheduled before use. We have different types of CPU scheduling algorithms. First come first served scheduling, shortest job first scheduling, priority scheduling, round robin scheduling, multi-level queue scheduling, multi-level feedback queue scheduling. Now we are going to see about first come first served scheduling. The process that requests the CPU first is allocated the CPU first. It is non-preemptive scheduling technique. The implementation of first come first serves policy is easily managed with the first in first out queue. Let's solve a problem using first come first serve scheduling. We have three processes P1, P2, P3 and the burst time is also given for the corresponding processes. The burst time of P1 is 24 milliseconds. For P2, its burst time is 3 milliseconds. For P3, the burst time is 3 milliseconds. Arrival time is not given in the problem. So we are going to consider all the three processes are arriving at the same time. At 0th milliseconds, all three processes are arriving and all three processes are entering into the ready queue. Now, we have to calculate turnaround time and then waiting time. For calculating the turnaround time and waiting time, completion time is required. In order to find that, we are going to draw the Gantt chart. At 0th millisecond, P1 process is entering into the CPU. P1 starts its operation. P1 starts its execution. Since its burst time is 24 milliseconds, it completes its operation at 24th milliseconds. Since it is first come first served scheduling algorithm and also non-preemptive scheduling algorithm, P1 completes its operation. After the completion of P1 only, the other process enter into the CPU. Now assume that P2 is entering into the CPU. Its burst time is also 3 milliseconds. So at 27th millisecond, P2 completes its operation. Now after the completion of P2, P3 is entering into the CPU and it is starting its operation, that is its execution. Its burst time is also 3 milliseconds. So at 30th millisecond, P3 completes its operation. Now this is what is the Gantt chart. From the Gantt chart, we can find what is the completion time of all three processes. For P3, the completion time is 30th millisecond. So we are entering that here. At 30th millisecond, P3 is completing its operation. P2 completes its operation at 27th millisecond. So completion time of P2 is 27. Then completion time of P1 is 24. So we found completion time of all three processes. Now from the completion time and arrival time, we can calculate turnaround time. The formula for calculating turnaround time is completion time minus arrival time. So for the first process P1, the completion time is 24, arrival time is 0. So turnaround time is 24 minus 0, we are getting 24. This is what is the turnaround time. For P2, turnaround time is its completion time 27 minus its arrival time 0. So its turnaround time is 27. For P3, its turnaround time is 30 minus 0, which is equal to 30. So in that way, we found turnaround time of all the three processes. Now from this, we are going to calculate waiting time. The formula for calculating waiting time is turnaround time minus burst time. Burst time is already given in the problem itself. Turnaround time we have calculated already. From these two, we can find what is the waiting time. So for the first process P1, its turnaround time is 24. Its burst time is also 24. We are getting waiting time as 0. And for the second process P2, its completion time is 27, but turnaround time is 27. Okay. And the burst time is 3. So turnaround time 27 minus burst time 3, we are getting 24 as the waiting time. For process P3, its turnaround time is 30 and burst time is 3. So 30 minus 3, we are getting 27 as the waiting time. Now we have calculated turnaround time and waiting time of all three processes. Now we are going to calculate average turnaround time and average waiting time. For that, first of all, we are going to calculate total of all the turnaround time. So 24 minus 27 plus 30, which is equal to 81. We need average turnaround time. So average turnaround time is equal to 81 divided by 3, which is equal to 27 milliseconds. This is what is the average turnaround time. And now we are going to calculate average waiting time. For that, first of all, we have to calculate the total of all the three waiting time. So it is equal to 0 plus 24 plus 27, the total waiting time, which is equal to 51. So average waiting time, which is equal to 51 divided by 3, which is equal to 17 milliseconds. In this way, we have calculated average turnaround time of these three processes P1, P2, P3 is equal to 27 milliseconds, and average waiting time of these three processes is equal to 17 milliseconds. We have solved this problem using first come first served scheduling algorithm. Thank you.